In the quiet hours before dawn, when the world feels suspended between night and day, astronomers around the globe are peering into the vast darkness above us. Their telescopes, pointed toward distant corners of our galaxy, are searching for something that has captivated human imagination for centuries. Other worlds that might harbor life. What they have discovered in recent years has fundamentally changed how we think about our place in the universe and about the very definition of what makes a world suitable for life. Imagine standing in the control room of one of these observatories, surrounded by the gentle hum of computers and the soft glow of monitors displaying data from stars so distant their light began its journey to us before human civilization even existed. The researchers here work with a patience that mirrors the cosmic timescales they study, waiting months or years for a single measurement that might reveal the presence of a planet orbiting a far-off star. When such a discovery is made, it arrives not with fanfare, but as a subtle dip in a star's brightness, a whisper of shadow that speaks of worlds beyond our solar system. The story of these distant worlds begins with a simple yet profound realization. Earth, our blue marble suspended in the cosmic dark, might not be as unique as we once believed. For generations, we have thought of our planet as the gold standard for habitability, the perfect balance of temperature, atmosphere, and water that allows life to flourish. But as our instruments have grown more sophisticated and our understanding deeper, we have begun to discover planets that might actually be more hospitable to life than our own homeworld. These discoveries unfold in the laboratories and observatories where dedicated scientists spend their days analyzing the faintest signals from space. Dr. Sarah Chun, working at her desk in a research facility overlooking the Pacific Ocean, examines spectroscopic data that reveals the atmospheric composition of a planet orbiting a star called Kepler 442. The numbers on her screen tell a story of a world with a thicker atmosphere than Earth's, one that might provide better protection from harmful radiation, while still allowing liquid water to exist on its surface. Her colleague, Dr. Marcus Rodriguez, reviews temperature models for another distant world, one that orbits its star at just the right distance to maintain not just liquid water, but vast oceans that never freeze and never boil away. These researchers speak of something called the habitable zone, that narrow band of space around a star where temperatures are neither too hot nor too cold for liquid water to exist. But their recent work has revealed that this zone might be more generous than we once imagined, and that some planets within it might offer conditions more stable and nurturing than anything we experience on Earth. The implications of this discovery ripple through the scientific community with quiet excitement, like ripples spreading across a still pond. As the seasons change and the Earth tilts on its axis, bringing us our familiar cycle of winter and summer, these distant worlds experience their own rhythms. Some orbit red dwarf stars, smaller and cooler than our Sun, but so long-lived that they will continue shining for trillions of years. A planet in the habitable zone of such a star might experience a climate so stable that it changes, little over geological time periods that would see continents drift and mountain ranges rise and fall on Earth. Imagine a world where the weather patterns established billions of years ago continue virtually unchanged, where evolution has had not just millions, but potentially billions of years to develop complex ecosystems under perfectly consistent conditions. The researchers studying these worlds work with instruments that can detect the chemical signatures of distant atmospheres, reading the composition of air that surrounds planets hundreds of light years away. They have found worlds with atmospheres rich in water vapor, others with the perfect balance of greenhouse gases to maintain warm temperatures without the runaway heating that transformed Venus into a hellish wasteland. Some of these planets are larger than Earth, with stronger gravitational fields that might hold onto their atmospheres more effectively, preventing the slow leak of gases into space that our own planet experiences. In a small office lined with star charts and computer models, Dr. Elena Vasquez examines the data from a planet designated TOI 715b. This world orbits a red dwarf star just 137 light-years away, close enough in cosmic terms that its light left the star when Earth was in the midst of its industrial revolution. The planet appears to be what astronomers call a super-Earth, roughly twice the size of our world, with a mass that suggests it might have a substantial atmosphere and possibly vast oceans. The star it orbits is quieter than our Sun, producing fewer of the violent flares and radiation bursts that can strip away a planet's protective atmosphere over time. The daily routine of these discoveries follows patterns as regular as the rising and setting of the Sun. Each morning, new data streams in from telescopes positioned around the world and in space. The transiting exoplanet survey satellite, orbiting high above our atmosphere, continuously monitors thousands of stars for the telltale dimming that indicates a planet passing in front of its host star. Ground-based observatories in Chile's Atacama Desert, where the air is so clear and dry that it seems to barely exist, use sophisticated instruments to measure the tiny wobbles in starlight caused by the gravitational pull of orbiting worlds. Meanwhile, in another part of the world, researchers at the European Southern Observatory are tracking the subtle wobbles of stars caused by the gravitational pull of orbiting planets. Their measurements reveal worlds that might experience seasons lasting not months, but years, due to their longer orbital periods. Such extended seasons could create climate patterns utterly foreign to Earth, with growing seasons that stretch across what we would consider decades, allowing for the development of ecosystems with life cycles and evolutionary pressures entirely different from anything we know. The story of these discoveries is also one of technological marvel. The instruments used to detect these distant worlds are so sensitive they can measure changes in a star's brightness equivalent to a mosquito flying in front of a searchlight. The James Webb Space Telescope, with its gold-plated mirrors and infrared vision, can analyze the atmospheres of these worlds by watching how starlight filters through them during planetary transits. Each observation adds another piece to the puzzle of what makes a world truly habitable, and whether Earth's particular combination of features is actually optimal for life. Consider the planet K218b, a world about 124 light-years away that has captured the attention of researchers worldwide. This planet orbits within the habitable zone of its red dwarf star, and recent observations have detected water vapor in its atmosphere. But what makes this world particularly intriguing is its size and composition. It is roughly 2.6 times the radius of Earth and about 8.6 times more massive, giving it a substantially thicker atmosphere that could provide better protection from cosmic radiation and help maintain stable temperatures across its surface. The increased atmospheric pressure might also allow liquid water to exist at higher altitudes and across a broader range of temperatures than is possible on Earth. The implications of atmospheric thickness extend far beyond simple weather patterns. A denser atmosphere acts like a blanket, not only trapping heat more effectively, but also distributing it more evenly across the planet's surface. This means that temperature differences between the day and night sides of the planet, or between its polar and equatorial regions, would be much smaller than what we experience on Earth. For life forms that might evolve on such a world, this stability could provide an environment where complex ecosystems could develop without the dramatic climate shifts that have repeatedly disrupted life's evolution on our own planet. As winter gives way to spring in observatories around the world, new data arrives daily from these distant realms. Some planets appear to have magnetic fields stronger than Earth's, providing better protection from the harmful radiation that streams through space. The magnetic field of a planet acts as an invisible shield, deflecting charged particles that would otherwise strip away the atmosphere and bombard the surface with dangerous radiation. A stronger magnetic field could create a more stable environment for life, protecting not just the atmosphere, but also any complex organic molecules that might form the basis of living systems. Others have been discovered with multiple moons, which might create complex tidal patterns that could stir their oceans and potentially drive chemical processes essential for life. On Earth, our single large moon creates tides that rise and fall twice daily, mixing nutrients in coastal waters and possibly helping to concentrate the organic compounds that gave rise to the first living cells. A planet with multiple moons might experience a complex symphony of tidal forces, creating currents and mixing patterns that could be even more effective at supporting the chemical reactions necessary for life. The researchers studying these worlds often speak of them with a mixture of scientific precision and barely contained wonder, as if they are explorers mapping territories that exist beyond the reach of any spacecraft we might build in the foreseeable future. Dr. Chun, reviewing the latest data from the TRAPPIST-1 system, a collection of 7 Earth-sized planets orbiting a small red dwarf star, notes that 3 of these worlds lie within the habitable zone. What makes this system particularly fascinating is that the planets are so close to each other that if you stood on the surface of one, the others would appear as large as the Moon does from Earth, creating a sky filled with neighboring worlds. The TRAPPIST-1 system represents a type of planetary arrangement that might be common throughout the galaxy, but is utterly foreign to our solar system experience. The 7 planets orbit their star in a complex gravitational dance, with orbital periods that range from just 1.5 days to about 19 days. This means that the seasons on these worlds, if they exist at all, would be measured in hours or days rather than months. Such rapid orbital periods might create unique climate patterns, with weather systems that could circle the planet multiple times during what we would consider a single day. The implications of these discoveries extend far beyond the realm of astronomy. If planets more habitable than Earth are relatively common in our galaxy, it suggests that life itself might be far more prevalent than we have dared to imagine. The researchers working on these projects often pause in their calculations to consider what forms of life might have evolved on worlds with different day lengths, different seasonal patterns, different atmospheric compositions. They imagine ecosystems that have had billions of years to develop under conditions more stable than Earth has ever known. Some of these worlds orbit stars that are not just more stable than our Sun, but also much longer lived. Red dwarf stars, the most common type of star in our galaxy, burn their fuel so slowly that they can continue shining for trillions of years. This means that planets in the habitable zones of these stars have had, and will continue to have, vastly more time for the development of complex life than Earth has enjoyed. While our Sun will expand into a red giant and render Earth uninhabitable in about 5 billion years, these distant worlds might remain hospitable for thousands of times longer. The concept of deep time takes on new meaning when considering these super-habitable worlds. On Earth, complex life has existed for only about 600 million years, a brief moment in cosmic terms. But on a planet orbiting a red dwarf star, evolution might have had 10 or even 100 times longer to work its transformative magic. The diversity and complexity of life that might have evolved on such worlds could be beyond our current ability to imagine, shaped by billions of years of stable conditions and gradual change. Recent discoveries have also revealed planets with characteristics that might make them more suitable for life than Earth in surprising ways. Some super-Earths appear to have plate tectonics that are more active than our own planets, which could help regulate their climate over geological timescales. Plate tectonics play a crucial role in the carbon cycle, helping to maintain the delicate balance of greenhouse gases that keeps a planet's temperature within the range suitable for liquid water. More active tectonics might mean better climate regulation and more stability over the long term. Not far from where this story began, in the quiet hours when most of the world sleeps, astronomers continue their patient watch. They are part of a generation of scientists who have fundamentally changed our understanding of planetary systems and the potential for life in the universe. Their work suggests that Earth, rather than being the best of all possible worlds, might be just one variation on the theme of habitability, and perhaps not even the most favorable one. The planets they study orbit stars that will continue burning long after our Sun has exhausted its fuel and expanded into a red giant. These worlds exist in a universe where the conditions for life might be not just possible, but optimal in ways that make Earth's environment seem almost precarious by comparison. As we learn more about these distant worlds, we are forced to reconsider our assumptions about what makes a planet suitable for life, and whether the characteristics we consider essential might actually be limitations rather than advantages. These discoveries invite us to expand our conception of home. While Earth remains the only world we know that harbors life, the universe appears to be filled with planets that might be even better suited for the development and sustenance of living things. As we continue to study these distant worlds, we are not just learning about other planets, but gaining a deeper understanding of our own. The gentle light of distant stars, carrying with it the secrets of worlds more habitable than Earth, reminds us that we are part of a universe far more rich with possibility than we ever dared to imagine. The search continues, patient and methodical, as humanity slowly comes to understand its place in a cosmos that may be teeming with worlds even more welcoming to life than the one we call home.